Give it a big round of applause for James Titcomb.
Okay. Hi, everyone. Sorry, set up now. How are we all? I'm all that stands between you and happy hour now. So I have your attention, right? My name is James Titcomb. I've been doing PHP since around 2002, programming since before that. As the branded shirt, I'm the only one at Rove that wore the branded shirt, just so you know my dedication there. Anyway, so you joined a new team, right? This is very exciting. Picture this, all right? First day on the new team, you're feeling great, yeah? You're excited to dig into some awesome new code. You grab yourself a cup of Yorkshire tea, grown in Yorkshire, obviously. You start settling into the work. Your elephant's at the ready to help you rubber duck. Wait, what is that? Something catches your attention. You think. What's this code doing? This doesn't seem right. Oh no, what is this? Who would do this? Oh my goodness, it gets worse. What's happening here? What in the fresh hell is that doing there? Why would you encapsulate the global state in that singleton like that? Why is the container available in a static object? Where did it all go wrong? What life choices led me to this inescapable hellfire pit of doom? What did I do to deserve this monstrosity spawned from the bowels of existence to be thrown into my brain mist and to decimate my very fabric of existence? Why am I screaming at a fluffy toy? How did I get here? They asked me in the interview whether I could reverse a binary sort tree. They made me do it on a whiteboard. I thought I'd be working on complex algorithms. Instead, I'm stuck with this horrible code. It's awful. It's legacy. So I start with a question to you all. You don't have to answer it. It's rhetorical. I'll answer it. What does legacy mean? Because there's an elephant in the room. Don't worry, that's my one terrible pun allowance used. It can mean old code, right? Code that uses outdated patterns. Code that's obsolete, but it's still sort of kicking around there doing its thing. It could be difficult to maintain code. It could be code that uses old frameworks that aren't maintained or libraries that aren't maintained anymore. Could be fragile or code that just no one wants to touch at all because they're like, if you touch that bit of code, everything will break. And then I'll say, I told you so. And also systems that are expensive to replace as well. But it can also mean code that's working, right? Code that still actually provides value. And that's important. And it could also be code that you've just written. So, to quote my friend and colleague, Sergeant Vranak, code can be in two states, in production or almost useless. A common cause of so-called legacy code is fast iteration, right? Just harking back to Marco's talk just then, he's like, when you're first prototyping, just smash it out there in an index.php. It doesn't matter, it's fine. But as soon as you've done that, it's already legacy, in quotes, code. So you can imagine this sort of thing happens in startups a lot, right? Because that's how you get things out quickly. You build it up quickly. You use some kind of frameworks and tools and stuff that help you push that stuff out as quickly as possible. Use some library that magically takes all the pain away of doing whatever you're trying to do. But the most important thing about doing that process is that you're producing that immediate value straight away. You're delivering what that business needs to operate. So you cut corners, of course, right? And that's how you generate that technical debt. And so invariably, if the product does end up being successful, and it's not just like some weird hipster smoothie maker or something, you're left with this so-called legacy, right? But this is okay. The other cause of legacy is years and years of stability. And this is, I've worked on many projects that are like this. They've been worked on and iterated on so many times that it's incomparable to the original version of it, right? Sometimes it's an application that's been running for years and years, small modifications here and there, you've added features, old features that you forgot about are still hanging around there. You've got inconsistent styles all over the place, different implementation practices all over the place. And you're obviously going to end up with dead code. And you're probably more than likely going to have lots of untested code as well. But there's still something important here. That code, although it's legacy and terrible and stuff, it still produces value, right? It's still letting that business operate. Maybe not optimally, but whatever. It's still doing what it's supposed to do, and that's okay. Legacy does not necessarily mean it's inherently bad. It doesn't mean it's broken. It does not mean you have to refactor it. We are obsessed with refactoring code, right? And this talk is not about refactoring code, but it is very relevant. It's about living with your code, hopefully happily, or as happily as you can be. But the point I want to try and get across is that sometimes it's better just to leave things alone, right? If it ain't broke, don't fix it, as probably some American said at some point. Software that's been running for years and years, or even decades, is not inherently broken just because it uses outdated patterns, so we don't do that anymore. It's fine. It still works. It still does its thing. So how do we tackle the existing code, right? Because it's not great calling it legacy because that carries so much mental baggage, right? It's just existing code. There's two main topics I want to discuss on how we handle this and live with this, right? First up is your general skills, right? Non-technical, soft skills, if you like, if that's what you like calling it. And this is the hard part for a die-hard techie like me. I'm one of those people, honestly, like Chris said this morning, if you want to get into programming because you don't like talking to people, I was one of those people, right, when I was younger. I was like, I don't want to talk to humans. I could just tap away at my computer all the time, typing up my awesome scripts, and so on. Yeah. I started programming at home on a computer by myself. I didn't have to talk to humans. So let's talk about that, because I've learned a lot in my career about talking to humans the right way and things like that. And that's business communication, right? For me, that would be my client. For you, maybe that's your boss or your client or, you know, other teammates and so on. Most importantly, you need to set and manage expectations, right? Keeping them informed about what's going on all the time is very important. Because if they come along and say, okay, how's this project going? And you're like, oh well, you know, we're having some issues somewhere along the line and so on. They're not going to be very happy because, oh, why didn't you tell me about this like a month ago when it was supposed to be delivered, right? Estimates are only a small part of that. Because at the end of the day, even if you somehow magically come up with a perfect estimate, things will always change, right? So don't leave your business in the dark, or, you know, who you're working for and things like that. Tell them what's going on, right? Communicate with them. If they're not technical in nature, you don't need to communicate the technical details, right? You can just tell them what's going on, right? They like to know this stuff. So you need some good communication with people like product owners, management, executives as well, if you have to be involved with that side of things. There's also your peer communication. That's the people you work with, right? These are mainly going to be sort of your other devs, your other tech folk, maybe testers, QA, and things like that. Other teams as well, like yourself, maybe you've got a small team and they've got another small team. You need to be able to communicate well with them. And certainly within your own unit team, whatever you call it, always be open with them and honest, right? Don't try and hide things. If you think you're falling behind on a deadline or something is just way more complex than you could ever have imagined, be open with them and just say, hey, look, I'm struggling, right? Your team should be, people you can open up to. And more often than not, if it's a good team you're in, they'll jump in and try and help it. Because at the end of the day, it's not just about you or them or anyone, it's the team as a whole, right? And you're trying to produce this goal of getting things working, delivering good quality software. With all the pandemic and stuff that's happening, many people who have started moving remote. I noticed in the UK, the government are like, no, you need to all go back to the office now. Shut up. Anyway, I've been working remotely for like 6 years or something, and it works nicely, right? Video calls, pairing is really, really valuable, even remotely. Some members of the team I work with, it really helps them as well, because they're like, it helps me get through that productivity. If I'm feeling a bit procrastinating or something, then we'll just dive on a call together, pair on something, and then they're like, oh yeah, okay, I'll take it from here. And then they spend the next week being hugely productive just from that one pairing session. But it's also getting that human communication as well, which obviously you're not going to get when you're working remotely, right? And you do need that. And also tech chats, like if you use Teams and Slack and stuff. Our Slack channel at Rove is horrendously busy. Sometimes usually it's work related. Sometimes it's not. Sometimes we just chat about stuff. We chat about meeting up at some awesome conference in Italy, for example. So maybe use MSN Messenger and things. Oh wait, hang on, that's not a thing anymore, is it? Oh dear, times change. So your team needs to agree direction, right? And by communicating well with them, you can do that, right? You can say, okay, yeah, we want to go in this direction, right? Discuss a strategy for how you handle those pain points and so on, and agree what direction you're going to go in. Sometimes you're not always going to agree, so it's always quite helpful to have sort of an architect, CTO, tech lead sort of person who can help guide you and work with them to get that direction as well. Weirdly, at Rove, we don't have that particular role because we all do that together. It's kind of sometimes you get a bit too many cooks spoil the broth sort of thing, but we work well together. That we respect that we've all got our own experiences, we've all got our own talents, and we try and work nicely together and respect each other for that. So when we do things, we try and get buy-in from the whole team on things like tools, best practices and so on that we want to adopt, processes like how we go about things, how we want to do branching and all that kind of stuff. So we define processes for things, especially for our expected typical workflow. And quite often for clients, we'll produce a documentation that says, this is how we work, this is how we're going to work on your project. And it's not always the same. For each client, they expect different things in different ways. So we will do things slightly in different ways, right? How do we research specifications? Some clients will give you really vague specifications like, we want this thing that does everything. Okay, great. Now we have to ask you lots of questions on how do you want it to actually work? And so we need to know how we're going to analyze those requirements and turn them into actual proposals for changes. And we'll write documentation and say, this is what we're planning on doing. And it gives the client an opportunity for that feedback. So they can say, oh, I know you're way off the mark. And we're like, well, you didn't tell us that. Or, oh yeah, we forgot about that. That sort of thing. And that's that very early sort of in the software development lifecycle communication that we need to nail there. So we also have team expectations for things like code style tools, linting, and what a testing strategy is going to be, what static analysis tool or tools we might use for a particular project, what are we going to do for pairing? Is it just going to be an ad hoc thing? Are we going to have a regular thing or whatever? What is your code review, peer review strategy, right? If you do that, which you should. What's your CI strategy? Like automate all the things, basically what it usually boils down to. And also your documentation expectations. So as Marco alluded to, obviously one of them is the same project I'm working on him with. We put the documentation in with the repository, in with the code, so that when you change it, you change the documentation at the same time, so you don't forget that. And then it's automatically synced into Confluence, where other people who care about Confluence can do that. And also the aftercare, the after support. Like once you've pushed something into this mythical production thing, how do you follow up things? Like how do you take care of it once something goes wrong? Who do you need to speak to? And making sure the client knows, okay, this person worked on this particular feature, so they are the best person. But if they're not available, we've also got other people on the team who are hopefully smart enough to help as well. So, we've always got fallbacks there. And as I said, we produce documentation out of this. We always aim to try and turn that tribal unspoken documentation that we say, oh yeah, this is how you connect to the VPN. And the number of times I've been like, oh yeah, you just do this and this and this because it's some weird VPN. Write it down in some documentation. And then say, this is how we do it, and that is a much better reference. And inevitably, we'll still go through it together anyway, and help out, right? That's what we do. So yeah, just smash a load of Markdown in, or whatever format you like. Put some nice graphs with it. We use Plant UML, which is some text-based thing, and it draws graphs, and they're all very pretty. And it's useful, right? Because it puts all that knowledge down into documentation. And also, when you're writing those documentations, consider the target audience as well. Sometimes we were writing things for other tech people at our client, right? Other departments, or DevOps people, or people who handle production, because we don't handle production, right? So it tells them how you're going to operate this. Or other teams, like, this is how you do it, integrate it with the front end, right? Sometimes they're intended for internal stuff, right? Like I said, like how do you connect to the VPN, right? What's our working flow going to be like, and so on. Sometimes it's intended for non-technical people, right? And you're explaining this is how a particular feature is supposed to work, and use lots of nice graphs and stuff so it's not too technical and overwhelming, because otherwise they're just going to start reading and be like, I'll grab a cup of tea then. So yeah, and when you're doing that, don't use like technical jargon, which they're just not going to understand, right? They don't care what an AWS is or anything like that. They only care that it does what it's supposed to be doing. So the other side of this is the technical skills and approaches, which, at least for me, is certainly more my comfort zone. Tools such as coding standards, static analysis, testing tools, and so on. So first up is reading code. Wow. This, at least for me, has been the most challenging thing to learn over the time. And it's actually far more important than writing code, right? Being able to read code that is there and understand what's going on without like saying, oh, I'm just going to start refactoring all of this, is very, very important. And the more code you read, the better you get. And eventually you'll start noticing little quirks in how each of your team writes things, or even previous members of the team. You can be like, oh, I can tell that person used to write that code who used to work here like 5 years ago, because I've seen that pattern over and over again written by them. Refactoring and rewriting code is only useful to the person actually carrying out that task, right? Everyone else has still got to read that code. So, and by readability, I'm not just talking about like nice coding style and so on. You can use tools to enforce that, but also making it understandable, using clear variable naming and things like that, right? So everyone else still has to read this stuff. They need to be able to understand what's going on. It takes a lot of mental energy to model code in your mind. So how do you get good at it? Well, practice, right? Like anything. Practice by reviewing code in open source pull requests, right? Start with a familiar language. I imagine the majority of us have dabbled with PHP once or twice in our lives. Start reviewing a project that is written in PHP. review merge requests that are open, for example, or even closed ones, it doesn't matter. Just read and try and understand what changes are happening and how they're happening and why they happen, and try and understand sort of the author's logic there. If you have pull requests or merge requests at your place of work, read them. Even if you think, oh, I've probably not got anything valuable to add as a comment, just read through it anyway and try and understand what's going on there. And yeah, like I said, if you're not sure, you don't have to leave any feedback. You don't have to be like, oh, why are you doing that? Or maybe you can just DM them and say, oh, why did you do this like this? And more often than not, they'll be happy to sort of try and explain it and help you understand. Using a step debugger as well is very, very helpful for trying to understand what code does, because you can actually see what the code is doing as it happens, right? You can stick a breakpoint on. Well, obviously, first of all, set up Xdebug, which certainly with Xdebug 3 and Xdebug Cloud and things like that you might want to use. It's very easy, and it helps you to visualize the flow and what the variables contain and what they're doing and how they're marshalling data around and so on. And it also helps reveal when variables are not clearly named as well. Like if you're just reading some code without running it, it might say, oh yeah, this is some string containing something. But actually somewhere down the line, someone refactored it and it now contains a number. And the only way you'll really see that is by using, obviously, static analysis tools, as we've learned today already, or by step debugging, saying, hey, that's not a string, that's a number. It's lying to me. So, another useful way of trying to understand code is to try and write tests for it, certainly if it doesn't already have tests. And try and write tests that characterize what the code is doing, because that's all you're really going to get out of that. Take a method or a function or something that's unclear, try and work out what it's doing by reading through the code. And really at the most basic level, that's give that function an input and see what it gives out as an output, right? See if it mutates state in some kind of weird way that you didn't expect. If you write a test, you kind of get a particular insight into what that code is doing. It's not a holistic insight, it's just like I said, a characterized, that's what that function does, just doesn't tell you what it means or why it's doing that. Another part of understanding code is also understanding how the business works itself, right? What are its goals? What's the key points of value in the business, right? Most of us will know at least that, hopefully. You know, what makes the business make money? Because ultimately, a business is there to make money so that it can continue doing what it's doing. What does the product do? Have a good understanding of it. Quite often, developers will work on projects and they'll just be writing technical stuff and not really care about what the product is doing. They'll just say, oh, they told us to do this, so we're doing it, right? So try and get that insight, because I think that's hugely valuable to understanding why the code does things. A success factor which leads to happiness is a balance of developer experience and of business value. By developer experience, I mean the ease of which developers can work happily, reducing frustrations, such as like working on a really old code base, working with CI that is unreliable, processes that aren't clearly defined, or not processes that aren't suited anymore because they changed, some kind of project management overhead, things like that. That all contributes to developer experience. And when developers are happy, they're going to be more productive. I think we can all agree on that. And by business value, I mean meeting those goals of the business, helping that business continue to make money. And as long as we've got that balance, right, we can't spend all of our time doing developer stuff and saying, oh yeah, let's use these new cool tools, or let's refactor the code so it's all amazing, at the detriment of the business actually making money, because then the business will run out of money and then you'll be looking for a new job. So we need to strike that balance. Um, so going back to refactoring, you need to ask yourselves, should we actually refactor? We need to weigh up our options. What is the actual maintainability of this code? How easy is it to change? And conversely, what's the cost of not changing that code? Like sometimes a particular code may be like costing the business money all the time. So if you don't change a particular piece of code, what's the cost there? And also, what's the cost on developer experience, as I've said? What's the risk of things breaking if you refactor? Is that risk something that you can take? Or if you take that risk and it brings down production for a couple of days, the business isn't going to be happy. You can mitigate some of these risks, right? Like that risk of breaking, you can refactor. You can add tests, right? First, before you refactor. If it's already working, just think, what can I break by refactoring this? You won't always think of everything. It's impossible. Think about the value to the business as well. If that particular piece of code is not really that important, I mean, you could say, well, that's a lower risk to refactor, so we can go ahead and do that. But does it actually provide any value to the business to do that? No, if it ain't broke, don't fix it, right? Sometimes refactoring is necessitated by change, though. Sometimes the business will say, okay, we need this new thing that does this, and you're like, oh, okay, so that means I need to refactor this bit, right? Or we need to fix this slew of bugs that we were putting off because they weren't that important. But we just need to consider if it's really needed, because refactoring is itself a risk. So don't just refactor because tech reason, right? Oh, look, let's put it in lambdas. Lambdas are great, yeah. For example, right, our team stopped using Mockery at some point, and we just wanted to use PHP unit only, right? We didn't change the existing tests that use Mockery because there wasn't any point in doing that. The tests were still doing what they're supposed to be doing just because they used Mockery. It's fine. We just left them there, and they're still testing, right? Refactoring those tests are obviously slightly lower risk, but is the time to do that? Would the time spent to change out Mockery for just using PHP unit in those cases worth it? No. We decided it's not really that important. There are a lot more other more important things to be doing. So yeah, we are generally, we all as developers just love refactoring, and I don't think we always do it for the right reasons. So I'm just saying, let's think about that a bit more. We don't necessarily need to look at our API and say, well, we've got a good RESTful API at the moment, but Rob did a great talk about GraphQL this morning and what its benefits are. Let's refactor it. Because what's the point? Unless you're going to get some actual tangible benefits there. So you've worked out you do need to refactor a part of the application, right? Limit your scope to what you're trying to do, right? I know it sounds kind of a lazy way of doing it, but do the absolute bare minimum to achieve what change you want to see. But do it iteratively, right? Make the small change and see how it goes, roll it out to production, and then do the next step. And so break it down, right? The cost of large changes is high, right? The more changes you have, the higher risk there is. And remember to balance those changes between the developer experience and the business value that they actually produce. So make a plan for it. Sometimes multiple rounds of refactoring might be necessary. And ensure you try and stay within that limited scope. And during that process, if you're like, oh yeah, we didn't think about that, add it onto the end, or put it where it's appropriate. Don't just drop everything and be like, okay, now we need to refactor slews of things, and suddenly this is a massive project. And you'll grind to a halt, so just take those baby steps. Tooling. So going back to general practices, invest in tooling, absolutely. There's been a few talks about this, so I won't go into too much detail. But investment time in setting up these tools to run in an automated way almost always pays off, as long as it's something that provides value, of course. Coding standards is an easy one. Pick a CS tool, whatever you like, roll it out. And so you're not disagreeing about, oh, that space should be wider than that space, because it doesn't matter that much, really. If you can automate it and get some tool to do it for you, that's better, much better, and there's less friction. Static analysis. To quote myself, I think that static analysis is probably one of the best things to happen to PHP since Composer. And I really do mean that, right? And I'm glad that Andre was able to come and do a talk on static analysis today. I watched it and I loved it. But yeah, roll out some PHP Stan. There's also Fan and things like that. They're all static analysis tools which help give you that insight into your types being used. But as I said, baby steps, right? Don't just enable the strictest static analysis and then try and fix all of the problems, because it will drain your soul and you will wish you were not doing that. Instead, set the strictest mode, I think, and then create the baseline and move on. Accept all the existing issues and just move on. Add it to your automated time, CI, and that's a great starting point. And as you refactor, fix issues that occur. Next step, refactor as you go along. Set up SARM in PHP Storm, which tells you as you're doing it. I created a specific nice color which tells me when things are going wrong, in SARM, for example. But it does ignore the baseline, which is nice. So I can see all of the existing issues. And obviously, you can probably do this with PHP Stan as well, of course. So yeah, don't get too far into static analysis whack-a-mole as well. Like what you'll find is when you're trying to fix these issues, is you'll fix one thing and it'll say, oh, there's 10 errors here in this file, and you fix one thing, and then it'll be like, okay, now there's 15, and you're like, what? And it can be a bit demoralizing. But that's because you've defined the type better, so the static analysis tool can say, oh, okay, so you're misusing it in all these places. Right? So you can decide then, you can either fix it because it's a real bug, or you can increase the baseline. But take a measured choice on that. Don't just be like, just add it to the baseline every time. Not always doing yourself a favor there. Testing is a big part of it, of course. Many times I've joined a team and they have no tests, nothing at all. Sometimes then we'll have some really vague effort at some tests, but they don't run them in CI because they're always breaking. So yeah, there's some room for improvement. But ultimately, good tests are better than bad tests, and bad tests are better than no tests, right? So just start doing it, right? Make good testing habits. For every single change you make like every pull request, merge request, feature, bug, whatever, it should get reviewed, it should get tested, right? And your reviewers need to say, no tests, no merge. Make all of the team reviewers as well. And this sort of goes back a bit to reading the code, right? If there's just one person reviewing code all the time, like Marco, you'll just get bottlenecked, because Marco is not a superhero. He is just human. He's a very nice human. I like him. He's a good friend of mine. But he likes to have vacation sometimes, believe it or not. So we all need to be mucking in and doing reviews, right? And make sure you feedback and don't gatekeep, right? There's a fine line, right? Reviews should be a discussion and saying, hey, what about this? Rather than being like, you're a terrible coder. You should feel bad about yourself. Why did you consider this life choice? And so on. So try and make some policies about how you go things about this, like usual policies, like no changes without tests, no merges with red builds, and so on. Those are fairly self-explanatory. But also make sure they're flexible, right? So I mentioned about increasing the static analysis baseline. Sometimes it's okay, right? Maybe you want a minimum number of reviewers, and so on. But all discussions on a merge request or pull request should result in either a modification to the change, sound reasoning why it is good, and then they're like, oh yeah, that's all good, yep. A ticket to defer the discussion to a later point, because maybe it's not important right now. And if someone takes time to review code and create discussions, don't just dismiss it, because it can be very frustrating for the reviewer as well, right? And remember, reviews aren't personal. It's not a critique on you as a person. It's we're looking at code and trying to make good code, right? Be like Kieran. He worked on a change for a while. It was reviewed by a team member. It does say who it is, but and the team member was like, I can see what you're doing. It's not quite the right approach. And we had a discussion about it as a team. And we're like, yeah, okay. And Kieran was like, oh, that's a bit rubbish. But he saw why sort of there was pushback on that. Marco wasn't criticizing Kieran as a developer. He wasn't saying, Kieran, you're rubbish. Okay, maybe a little bit. Not normally, anyway. So yeah, one approach to tackling no tests is just to start writing Happy Path as quick as you can, right? It doesn't matter how you do it, right? Could be an API, just run the application, test the endpoints. Just having something as a starting point is much better than nothing. But make sure it keeps running in CI, make sure it's green all the time, right? And just focus then from that point on to the critical functionality, right? And say, okay, well, taking payments is a very important part of this application, so let's test that, make sure that always works from now on, and so on. It's not always going to be a forever solution. You need to be able to say, okay, we've written some better tests for this now, so go back and delete the old ones. And that's okay, right? Always have changes with tests from now on, right? Limit the scope of those initial tests if you can. They're valuable, but they are limited in value. And they tell you when things change. But yeah, just don't be afraid to delete the tests once you've done it. If you keep fixing the test over and over again, maybe it's not a very valuable test. If you have a very well-tested component, good behavioral tests, good integration tests, good unit tests, consider that initial sort of, let's just get something out there, still provides value. If it doesn't, delete it, yeah? You need to get to that point of safety where you've got that confidence. As I said, make sure they run in CI. You always want that red-green feedback, right? Get to that point where if it's red, you don't merge it, right? And very, very, very rarely will your trunk branch start failing for whatever reason. Automate it all, right? CS checks, tests, static analysis, open API description linting. There's so many tools. Documentation generation, code coverage, ORM and migration checks and things like that if you use that. Security checks and so on. It should all be automated. It should all go into your CI pipeline, right? So legacy, existing code, is not bad as long as it produces that value, right? You don't always need to refactor it, but make sure you've got that confidence when working with it, and that will make you happier, right? And automate it all. Thank you very much, everyone. Any questions? If we've got time for questions.
Thank you, James. Are there any questions?
No, everyone's like, happy hour, come on. Can I just say, before we depart for today, a massive thank you to all of the organizers for taking a bit of a risk in this pandemic time and putting on an in-person conference again so that we can all meet here. Thank you very much, all of Grusp. Thank you.
All right, so I guess that's it. Thanks again, James, and I guess it's happy hour time. So I will see you downstairs and see you tomorrow.